We begin Unit 2 with Chapter 5, which are polynomials, right? Chapter 5 deals with polynomials, polynomial functions, polynomial equations, polynomial expressions. So in the first unit, mainly we were dealing with linear functions, right? I mean, we had a little bit of absolute value functions in there, we did a little bit of trig, but in general we were dealing with linear functions. But now, of course, we're going to move on to polynomial functions, which are a bit more complicated than linear functions. All right. So first things first, what is a polynomial expression? All right. So a polynomial expression, right, not a function, right? Expression meaning that there would be no equal sign in it, is a sum of terms where all the variables have natural number exponents. All right. So that's the key. The key that identifies a polynomial is that all the variables are going to have natural number exponents. All right. So, for example, that expression there, negative 3x to the fourth plus the square root of 2x squared minus pi x plus 4. That is, in fact, a polynomial expression. Now, I think sometimes what would throw people off here is the square root of 2 and the pi, right? The square root of 2 and the negative pi are actually coefficients, right? So they're irrational coefficients. So these polynomials can have irrational coefficients. The coefficients don't have to be rational numbers, right? Like here you have a negative 3, which is a rational number, and here you have a 4, which is the constant term, which is a rational number. But the square root of 2 and pi and negative pi are actually irrational numbers, which is fine, right? The key is every exponent of a variable must be a natural number, right? And like that one there, you don't see it, but there's actually a 1 there, right? So in this case, the exponents are 4, 2, and 1. Therefore, that is a polynomial expression, right? So really what you're doing is you're just looking at the exponents of the variables, making sure that they are natural numbers, okay? So I gave you an example of a polynomial there. Really, probably a better question here, instead of are these polynomials, is what I'm going to do is I'm going to give you examples of things that aren't polynomials and say why they aren't polynomials. Okay, so if I wrote something like 2x to the negative 3 plus 4x plus 2, that's not going to be a polynomial, and we'll get into why in a second. If I wrote something like negative 4 radical x plus 6, that wouldn't be a polynomial. And if I wrote something like 3 over x to the third minus 2 over x plus 5, that wouldn't be a polynomial either, okay? So the first one here, 2x to the negative third plus 4x plus 2, that one is pretty clear why it's not a polynomial, I think, right? Right here you've got a negative exponent. So that's not a polynomial because it's got a negative exponent on x there, okay? So that one is pretty easy to see. Now the second one, negative 4 square root of x plus 6. Now, depending on your math background, you might not have seen this before, but the problem with this one actually is this square root, right? This one is not going to be a polynomial, and the reason being is that a square root is actually a fractional exponent. It's really the half power. So again, the reason that wouldn't be a polynomial is because a square root is actually a fractional exponent. All right, so that one might have been a little bit tricky. And then, of course, the third one is probably the hardest one, because you look at this and you say, all right, well, 3 over x to the third minus 2 over x plus 5, well, the definition was all the variables have to have natural number exponents. And you see this is a 3 here, and this is a 1. The problem is they're in the denominator. So what you got to realize is that this expression here is actually that expression there, right? If you remember from exponent rules, whenever you might have done those previous class, right, an exponent in the denominator, a positive exponent in the denominator, would really be a negative exponent. Okay, so that 3 over x to the third is really 3x to the negative third. The 2 over x is really 2x to the negative 1, right? So now it's clear that, hey, all right, this is not a polynomial because we've got negative exponents, right? So bottom line is, if you've got a negative exponent, a root, right, which is a fractional exponent, or if you really have a variable in the denominator, because a variable in the denominator is going to mean a negative exponent. Those things wouldn't be polynomials, okay? And then just a little terminology here, monomial, binomial, trinomial. A monomial is just a single term polynomial. So how do you identify terms? How do you separate terms? You separate them by the plus or minus signs, right? So if I just wrote a single term, you know, like, okay, negative 6x squared y squared, that would be a monomial because it's a single term. Now, if I took negative 6x squared y squared and added it to 4xy squared, that would actually be two terms. So that one is going to be a binomial. And then, of course, if I did negative 6x squared y squared plus 4xy squared minus 3xy, that's now got 1, 2, 3 terms. So that one would be a trinomial. Okay? And one little thing to note is, when there's a minus sign like this, you really think of this as a plus a negative. So then if you were going to identify the terms here would be negative 6x squared y squared, 4xy squared, and negative 3xy, right? So basically, if there's a negative sign in front of it, you consider that part of the term, right? Because technically terms are added, so you really want to change all these signs into addition. Right? So minus was really plus a negative, so that's really a negative 3xy, that third term. Okay? So that's just the basics of polynomials.